Okay, so today we're going to go over interval notation. I have linked this PDF. If you want to write directly on it, you will need to print it or use your Kami app, or you can just take down notes on your blank paper, or this answer key will be posted. So if you just want to watch the video and then use the resource provided, you can do that as well. And so we're going to review a concept from Algebra 1 and then take it to the next step for Algebra 2. So in Algebra 1, we learned to represent numbers on a number line or graph using inequality notation. So we have two examples written out for us in this table. This first example, we are representing numbers between 3 and 5, including the 3, but not the 5. And so looking at the graph, we have a closed circle on the -3 and an open circle on the 5 to show we want to include the -3 but not the 5. And then to include the numbers between them, we have shaded between the two numbers. And so to represent that in Algebra 1, we used inequalities. We use inequalities in Algebra 2 as well, so you will need to be comfortable with both inequality notation and interval notation. And so in inequality notation, we always put the variable x in the middle, and then I always say the alligator sign, the inequality sign, always eats to the right, because we always write from least to greatest, left to right. And so if we're talking about a general number line, negative infinity to positive infinity always goes from left to right. And so the lower number, -3, goes on the left. The higher number, 5, goes on the right. And then x goes in the middle, 2 alligators on each side, eating to the right. Now, this -3 has a line underneath because we are including it. We have a closed circle there. This 5 does not have a line because we do not want to include it. We have an open circle over here. And so for interval notation, we have different notations to represent closed circles and open circles, just like we do for inequalities. And so on your notes or to the side, you're going to want to write this down. We have closed circles and open circles. And then for the closed circle, we draw a line underneath the inequality. For the open circle, we do not. And so for interval notation, we use a bracket, a square bracket, to represent a closed interval. We used an open parentheses, a curvy parentheses, just like we do here for an open circle. So open circle, no line, curved. And then closed circle, you need to include the line and it needs to be a square. And so ways we can remember that is open circle starts with an O, and this is part of an O, it's curvy. And then for the closed circle, if you take the time to color in the circle, you're going to take the time to draw the line. Okay, and so we're just going to go through this table and fill it in. And so parts of the table is filled in for us. We just need to fill in the missing pieces. And so for the next example, it's completely done for us. I'm going to switch colors. And so this one says x is greater than 2, and so it's referring to numbers strictly greater than 2, not including 2. So in the graph here, we see we have an open circle on the 2, and to be greater than, we shade towards the positive infinity to the right. And so in interval notation, our lower number is 2, and then our higher number, there isn't a higher number. It goes on to positive infinity. And so if I were to represent inequality notation, I would put x in the middle. Alligators always eat to the right. and then 2 is the lower number, and infinity is the higher number. And so I am not going to put lines under either of these inequalities because I am not including the 2, and you never get to include infinity. Infinity will never be included. You can't reach infinity, so you can't include it in your interval. And so the corresponding interval notation would have a parenthesis on the 2 and a parenthesis on the infinity. Okay, and so one important note is that the smaller number will always go in the left. You'll have a comma and then the higher number here. You don't write a variable within these symbols, and positive infinity will never be over here in the left side, just like negative infinity will never be over here. And then we always write low to high. Okay, another note is that x is greater than 2. These two notations I've written here are the exact same thing. In Algebra 2, we don't usually use this notation. We use this one. All right, switching colors for example 1. Okay, so this says x is less than or equal to 3, so I'm going to start with the graph. And to make your number line, I only put the number I care about, which is 3. And then this says less than or equal to, so I'm going to use a closed circle to show I want to include it. And since this is a less than sign, the way I remember that is that if you stand up a less than sign, it makes an L for less than. That's going to be the numbers towards negative infinity. And so that would include the 2, the 1, 0, all of those numbers are less than 3. And so in words, you can write the word numbers every time, or you can just say less than. So numbers less than or equal to 3. And so over here, I'm going to go ahead and do my parentheses for the negative infinity, because you never get to include the negative infinity, followed by a 3, and I'm going to put a bracket on the 3 since I'm including it. Negative infinity was the lower endpoint, 3 was the higher. Infinities never get a bracket. This 3 gets a bracket because we're including it. Okay, for example 4, this goes from negative infinity to 4. So if I put that on the number line, negative infinity is to the left. I'm just going to put 4 right there. There is a parenthesis here, so I'm going to put an open circle. And since we're going to negative infinity, I'm shading to the left. So in words, that's numbers less than 4. And since we're not including 4, I want to add the word strictly. If I just said numbers less than 4, I wouldn't include it. You assume you don't include it unless specified. And so numbers strictly less than 4, strictly just make sure it's super clear. Okay, and so in inequality notation, I put the variable alligators on the left and right. Negative infinity is the lower endpoint. 4 is the higher endpoint. And just like these two examples above, they didn't write this part. We don't usually write that part. We don't write infinities in inequality notation. We only use them for interval notation. And so x is less than 4 is how you would see it on a multiple choice test. Okay. For number 3, they've given us a graph that goes from 2 to 6. And since both of these are closed circles, it's numbers between 2 and 6. including 2 and 6. You could also put a comma and just say inclusive for both. Okay, and so in interval notation, we are going to have brackets on both numbers from 2 to 6, and then brackets because we're including both. And so in inequality notation, put your variable, alligators eat to the right, 2 is the lower endpoint, 6 is the higher endpoint, and both alligators or inequality symbols need lines under them. Okay, for this one, we have another one-sided inequality because I see that infinity. So on my number line, it goes from 5 to positive infinity, and there's a bracket. This bracket tells me I want a closed circle, and since positive infinity is my higher endpoint, I'm going to shade to the right. Notice infinity has a parenthesis. You never get to put a square bracket on infinity. And so that's numbers greater than or equal to 5. And so in Algebra 1, our lower endpoint was 5, x in the middle, alligators eat to the right. Our higher endpoint was infinity. We include the line under it, or if we're writing it as a one-sided, x is greater than or equal to 5. This is the preferred way. We always write the variable first on these one-sided inequalities, and then if it's greater than, we have the backwards L. If it's less than, we have the L. Okay? For this next one, we have a closed circle on 1, and it's shaded to negative infinity. So that's numbers less than or equal to 1. Make sure that was actually closed in. Okay, and so negative infinity is our lower endpoint. 1 is our higher endpoint. Infinities always get parentheses, and since we're including the 1, we get a bracket. And so in inequality notation, numbers less than or equal to 1 looks like that. Okay, so number 6, we have 2 inequalities. And we'll see that a lot when we start talking about domain and range. But to represent 2 inequalities in interval notation, we're going to need 2 intervals. Okay, so let's go ahead and do the graph. We're going to put 1 on the graph, and we're going to put 5 on the graph. And so this says x is less than 1. Remember, if I stand that up, it makes an L. And there's no line, so I'm going to put an open circle on the 1. And then this says x is greater than 5, since the backwards L. And then it has the line, so it's greater than or equal to. So we're going to put a closed circle. And so less than is to the left. And so I'm going to shade to the left of 1, or greater than or equal to 5. So from the 5, we're going to shade to the positive infinity. So in interval notation, we go from left to right. So negative infinity is this lowest endpoint. And then we stop at 1, so comma 1. and it's an open circle, so I'm going to put a parenthesis. I'm going to do better than that. Negative infinity, comma, 1 parenthesis. I've only represented this part right here. Or, and the lazy mathematician way to write or is we use a U for union with. And then our next interval goes from 5, including the 5, to positive infinity. Remember, infinities never get brackets. They only get parentheses. So a couple things I want to point out here is that negative infinity will always be on the far left of your interval notation. Positive infinity will always be on the far right. These will never be switched. Okay, so in words, numbers less than 1, and you can add the word strictly right here, or greater than or equal to 5. I'm going to leave number 7 for you to do on your own and check with the key. For number 8, this says all real numbers. And so all real numbers means the entire number line is fair game. I'm going to shade the whole thing. So that means we're going from negative infinity to positive infinity. So in interval notation, that's going to go from negative infinity to positive infinity. You're going to see this a lot. So all real numbers is represented by negative infinity to positive infinity. And then a symbol that we can use for inequality notation is an R with 2 lines. And so you'll also go back and forth between these two symbols. And so recognize that these are 2 different ways to represent all real numbers. In interval notation, it's negative infinity to positive infinity. In inequality notation, we just use this fancy R with 2 lines. Okay, and then I'm going to leave 9, 10, 11, and 12 for you to do on your own and check with the key. The last one I want to talk about is number 13. This X is not equal to 4. We will also be seeing this a lot in this course where you exclude just one number. And so this means we can have any number, all real numbers, just like we had up here, except 4. 4 is the only one not allowed. So on a number line, I've seen a lot of students go above 5 and less than 3, but then you're leaving out all the numbers like 4.5 or 3.5. The only number we want to exclude is 4. And so on 4, you're going to have an open circle, but you're still going to shade everything above 4. So this includes 4.5, 4 3/4. And then we shade to the left of that open circle to get all of the numbers less than 4. And so another way we could say X is less than 4 or X is greater than 4, both strict as long as it doesn't equal 4. And so using interval notation, we go from negative infinity to 4, parenthesis, union, 4 to infinity. We have parentheses on both numbers. So this part on the left refers to all the numbers less than 4. And then this part on the right, 4 to infinity, refers to all the numbers greater than 4. And so on your own, I want you to fill in 9, 10, 11, 12, and then number 7, and then check with the answer key that's going to be posted.